All right, everyone. Welcome to week 13, day 3 of the world's most fabulous computer science 41 class going on currently at this semester at Clovis Community College. So, we are going to, first of all, answer any questions you guys have about the assignment. It is due on Monday. Do you guys know how to use Excel? Do you know how to graph things in Excel? Do you know how to copy-paste out of PuTTY? These are all probably important things to figure out. Server is currently being, one of the two cores is being hit by Thompson right now. So get in while the getting is good. There's one core available. Act now, supplies are limited. I just got out of a meeting with Nico and Tang and somebody, Laden, the other computer science professor here, and the network administrator at the district level. And so we're going to be setting up a new server that is quite beefy, actually. And that will allow this assignment to take place a little bit easier. Our current ETA is a month from now, so May 9th. We might do one more benchmarking assignment with you guys. You guys can maybe hammer the new one, which would be kind of cool. So, could you explain the final test we need to do? The mixtape one, I call it. So the final one you need to do is a mix of the different operations. So what I would do is, well, you can technically do it any way you want. You just need to write and you report what you did. Because, right, if you do an insert, then a remove, then a search, that's going to be different than an insert, a search, and a remove. Right? Because there's different load levels, right? So, or maybe it won't. It depends on your implementation. So all you need to do is to document your input files, right? So for this input file, because input and search is straightforward, input, remove, whatever. You just document what's in the input files. I did a million inserts, I did 500,000 removes, I did 250,000 searches, whatever. Just report what was in it, because what you'll find out is that everyone's reports are actually different. Like you'll get different conclusions, and a lot of times the differences in runtime are due to one of two things. First of all, your implementation details, right? How did you implement deleting makes a big difference. There's all sorts of tricks that people do with hash tables to make them more performant. All those details translate into real world differences in the graphs. And second, what was your input files? So, are you doing this first, then this, or this, then this? And so, you just need to document what you did. Okay. And then the third option is your implementation is buggy, right? So a lot of students, I can tell their code's buggy just by looking at the graphs. And then I'll pull up their source code and be like, yep, they didn't do a hash table, right? So like if them main.cc, this is just a set demo, move main.cc to public, set serialize, set demo.cc, public, then main.cc. So let's say that you have a hash table. Don't care. Show you guys array. We haven't messed with arrays very much. These are C++ style arrays. Like a lot of you guys know this kind of array, int array, 1000 or whatever. Don't do this. Don't. There's maybe niche cases where you might need to do that. In general, don't do that. Okay. Just don't. Just trust me. If instead of doing that, you want to do this: array of integers of size 10,000. Named R. Okay. And then rather than using a magic number, what should we use? Rather than using a magic number, what should we use? R. Yeah, make a constant. Very good. And it's not int, it is a size t is the type. So size t is used anytime you're holding the size of an array or size of a vector. It is a type that on our system is basically a 64-bit integer, but it changes based on the architecture you're on. So if you're on a 32-bit system, a size t will be 32 bits. On a 64-bit system, it'll be 64. It's the right way of doing things. So I want to make a const size t called size equal to 10,000. And then I don't have a magic number in my code. In general, the only raw numbers you should have laying around are 0, maybe 1, like a plus plus, kind of thing is fine. But if you have numbers like 16 and 10,000, no, make a constant for it so it has a human readable interpretation. Okay. What is the difference between const only and const size t? What do you mean const only? Like that? Const is not a type, right? Const is const is called a CV qualifier. More C++ detail that you need to know. The C stands for volatile, which is not something you will encounter in normal programming. It's common in embedded systems where a variable could change. Somebody else could change a variable. So volatile, yeah. So volatile basically means don't rely on this variable being the same from line to line. Yeah. It's like if we had a volatile size, then if you counted size, a lot of times the optimizer would just be like, it's 10,000, right? It won't even store it in a variable. But when you have a volatile variable, that means somebody else could be changing it. So let's say somebody else has a pointer to this address of memory and could be messing with it and writing it in a different thread, then you need to flag it as volatile. So that turns off various compiler optimizations. It'll constantly reload it from memory and things like that. It's mostly used in things like embedded systems programming, where you have a hardware device that is writing to a variable. And so you can't rely on that variable being 10,000 and 10,000. It didn't change. Look, you see this? I set size to be 10,000. It should still be 10,000 here. It should still be 10,000 here. That's the logic the optimizer uses. However, if somebody else is going to be overwriting it, then you need to mark it as volatile. Okay. So const is it's not going to change. It's the opposite of volatile, right? Const is not going to change, and so when you mark things as const, it allows the optimizer to do its business. And it will oftentimes just erase the variable entirely, so it doesn't take up any RAM at all. It'll be hard-coded. Yeah, good question. All right, so we're talking about hash tables, right? So let's do a status thing as well. Status. This be a unsigned char or something like that, and put an enum class status. That stores char. These values are open. Okay, so we've got one array that holds the data that's going to be inserted. We got one array that holds if each bucket is open, filled, or deleted. Okay, so while true, cout, let's use read, int data equals read. Please enter an integer to insert the hash table. Okay, so how do we insert something into a hash table using linear probing? Volatile has nothing to do with the value. It's a hint to the compiler. The variable can be changed. Yeah, it's called a CV qualifier. So every variable can have a CV qualifier on it. It can have no qualifier, which means it's a normal variable. It can be C const, which means it won't change. And volatile means it can change even without you knowing about it, right? If you have a multi-threaded program, or like I said, an embedded system, oftentimes your hardware will be writing to variables, so you need to mark those as volatile. It's you don't have to worry about it for now. Okay. All right. So how do we find the bucket to put the data? We're going to insert the number 42. Let's say the user type's 42. Let's make the hash table smaller, I guess. See, I only have to change it in one place. Always use constants. If I didn't have a constant there, I'd have had to change it in 3 places, because I'm about to use the modulus with the size as well. So how do I find the bucket, people? What's in the bucket? How do I find the bucket to insert into? User typed in 42. We got a hash table of size 10. How do we figure out which bucket it goes into? Modulus size. Very, very good. So the bucket is size t. Which bucket we're going to write into is going to be the data value modulus the size of the hash table. And will this work with negative numbers? Maybe. Oh, let's find it out. Modulus can be weird and buggy with negative numbers. But we are using a size t, so it might overflow, but then it's doing modulus. So we'll find out. We'll find out if that works. Okay. And so if we typed in 42, we have a hash table of size 10. Which bucket is this going to try to put 42 into? Two. Very good. Two indeed. Dose. So, but we need to see if that spot is free. Thank you, Ada. We need to see if the spot is free first. And so, by default...
You're welcome.
By default, this should default to open, I believe. We'll find out. Okay. So if status dot at bucket is not equal to status open, see how bucket is not open. Otherwise, array dot at bucket is equal to the data. So if the bucket is free, we write the data in and mark the bucket as full. If the bucket is full, then right now we're just printing out bucket's not open, and we're not doing linear probing. We have a very bad hash table right now that only works without collisions. Okay. So let's compile this, see how this works. Run it. 0, we quit. Excellent. Let's insert 42. Bucket is not open. Yeah, so we're going to need to fill this with status open. So if you were wanting to fill an array with a value, how would you do it? In the source code I gave you guys, in the source code I gave you guys, I used resize because resize allows you to resize it and initialize it at the same time. But if you were the author of the standard library and you wanted to write a function, a standard library function, to fill an array with a value, what would you guys call it? Range-based for loop would work, sure. But there's a standard library function for it. What would you guys call a standard library function to fill an array? Philip? Hey, Bell's here. Bell, you want to talk to the class today? It is called fill. So we can call std fill, or just fill because we have used namespace standard, like a boss. Don't let the haters hate on from array.begin to array.end. And the values we're going to put in here is called status : open. So that fills the array with open. Does not like, cannot convert main status to int. What happened here? Rip. Isn't our array a pair? Yours is not, no. Why are you complaining about this?
It's because you're filling an array of ints with the statuses.
Yes. Thank you, status.begin. Why was it complaining about the header file, though? That's a weird place to draw the line. All right. There we go. All right, so 42, spot is available. 42 again, spot is not open. 52, spot is not open. What about 55? Spot's open. Okay. So we are hashing. Do you guys conceptually understand hash tables? Hopefully you did. Hopefully you did the reading, because that really helps conceptually, and I'm showing you guys the code side of things. So now we need to do linear probing. And such an extent as criticizing your library. Yeah, I don't know. You know, why did YouTube take down my Monday video? You violated the rules. Didn't say what rule you violated. Just you violated the rules. No appeal possible. Do you guys hate hash tables that much? Yeah. Yeah, YouTube said that no explanation given, and no appeal possible, no explanation. My Monday video violated the rules on YouTube. So I re-uploaded it, and it was fine. I have no idea what it was so angry about. All right, so we need to do linear probing, right? We need to do linear probing. So if the bucket's not open. Okay, so here's the thing. This is hashing, right? You jump to the bucket. If the spot's available, you write into it. And if the spot's not available, then you move to the right, okay? And so the easiest way of doing this is saying while the status is not open, and technically, yeah, that's fine. While the status is not open, and the status is not deleted, because if you ever find a deleted element, you can write into it, because we lazy deleted. So that means the spot's technically open for writing. It's not when you're reading, you have to keep going if the thing was deleted, because it was lazy deleted. There could be variables past that point. But if you write a new value in, you can write it into a deleted bucket. That's how you reclaim the deleted space. So while it is not, or we could just say while it is equal to filled, one way or the other. Okay, then we're going to move one to the right. So bucket is equal to bucket plus 1. This will have a problem of going off the edge of the array, and so we need to modulus it by the size, like that. And then the bucket will go one to the right, one to the right, one to the right. If it ever goes off the edge of the array, it wraps around back to 0, and it will keep going. And this will work fine, except there's an infinite loop if the hash table is full, which I'm not going to worry about right now, because you need to solve that yourself in the homework center. So this is a valid insert function, I believe. Let me just test it really fast. Infinite loop. Right. Okay. So I was saying, what if a student implements it badly? What if a student implements it badly? This right here is big O n, right? Worst case, it will Worst case, it will loop. Well, technically it's order infinite right now. It's an infinite loop worst case. But assuming we have a stop for it in there, we'll loop over the whole array. Now, how do students do this badly? They do this. They do the bucket or whatever, and then they completely ignore it because they don't understand it. So they write a for loop that looks like this. For status s in status if status is open, then write it into the. No, don't do this. Okay, I've said this several times. If you're using a range-based for loop with your hash table, it's for anything except maybe like printing it. Like if you just want to debug, print the thing to the screen. Like if any of your code is using like a range-based for loop or something like that, it's probably wrong. Because this will do an order in operation every time. What you want with a hash table is when the hash table is mostly empty, to just jump to the right spot, find the thing, return it, order one. Order one average case, right? And if you're doing this, you're just going to be looping over the whole damn thing every time. Every time, search. Like so many students wrote their search function by just searching through the entire array. Search through the entire array to see if there's a match in there. Return true. Don't do that. Don't do that. You will lose points. I will take points away from you. You do that. It's wrong. Wrong. This ain't the hash table anymore. Proper. Don't do that. Sure, you'll pass the test cases. Okay. Sure, you'll pass the test cases. But your code's not a hash table, so it's not. You did not actually do the homework assignment. Okay. Making a hash table that accepts duplicates. Yeah, right. They hate kids being in YouTube videos. Now, I mean, I re-uploaded it, right? And it worked fine, so I don't know. Okay, so Mr. Bell is here. Mr. Bell, would you like... have you talked to this class before? We invited you to speak, right? Is that right?
Yeah, you invited me.
Okay. So why don't you talk about your experiences, life lessons for students, things like that. And students, Mr. Bell here is the former TA in this class. He, let me give him an introduction. One of my best students. He graduated 2 years ago. Is that right?
Not sure.
Okay.
Yeah, I think it was 2-ish.
Okay. And so...
Clovis, yeah. Somewhere around there.
Somewhere around there. And then he went to CSUMB, right?
Yeah.
Okay. And has since... he TA'd for me for a number of semesters, did a really fantastic job TAing. And now you have a job in Texas, right?
Yep.
Are you in Texas?
Yeah, I'm in Texas.
Yeah.
For your computer science 1 class, thinking that they're reading about time zones.
Okay. So why don't you talk about your experiences? Yeah, give a TED talk. I'm going to go grab some cereal and I'll listen to it. Life lessons you have for students, what things they should focus on, what skills they need, applying for jobs, that kind of stuff. Okay. I'm going to go ahead and mute myself. Take it away, Mr. Bell. Everybody, please give him a clap emoji on Discord, and hopefully the recording will record this.
Do you want me to share my screen so I can kind of show stuff a little bit?
Yeah, go for it. And then I'll put that up on the stream over here. Yeah, I'll put it up. I'll put it up over here on the screen. Mr. Bell is live, and I'm gonna go not live. Let me turn off my streaming. Stop streaming. There we go, and we will watch your stream here, and pop it out. Snap it over here, and so we've got a stream of Discord. Okay. The world of ST.
So, kind of to go with this class, and I guess a little bit more of the 26 or your algorithms class. One of the biggest things is learning the C++ standard library. guys are going to have a ton of fun doing with the hash tables. That's super easy to do with the standard library, because there's literally functions that'll make a heap, push a heap, or pop a heap. It'll all be done for you. But that's probably not what Cranny wants me to tell you. So I guess we'll start with what I've done. So like you guys, I was a student at Provost Community College. And I don't know if I should have the chat open. Let's see. Yeah, whatever. So I did kind of the usual 40, 41, 26, and 50 at Provost Community. And then I went to CSUMB and we did a lot of things there. So I'll kind of go through the kind of coolest projects that I've done, because that sounds like the most fun. The first one was just a really simple RPG assignment, where it's just visual. You say your name, you got WASD to move around, and you can spread, or yes, you can interact with things and walk around, and that's about it. That was yes. I did all of my bachelor's degree online. My upper division classes were all online, so that I didn't have to move to Monterey, and I could stay and help Kearney. So, kind of the two most important things, I would say, I'm super all over the place, sorry. The two most important things I would say is learning Vim and how to use a terminal. I'm still learning how to use Vim all the time. So when I had to do a few of my classes, they gave us the option to either use, I should probably structure this a little bit better. You were up, okay. Clean portfolio, terminal isn't shell scripting. Yeah, a little bit of shell scripting. I've actually been writing a shell script for my job right now for basically duplicating folders and changing names of the files in them. It saves a lot of time and wastes a lot of time. So one of the classes I had for upper division wanted me to submit my files in a very specific way. And I didn't like their code formatting, so I didn't want to write my code in that format. So what I did is I made a shell script that would modify my code to look like theirs, or the way to change the formatting to the way that they wanted it, build the submit, and then save it in a different file, and then revert my code back to the way I liked it. So this is my shell script to submit my assignment, essentially. And so kind of learning a few command line things will make life a lot easier and more convenient. So sed is kind of for finding or replacing in files, and then I used a useful program, I guess, called A-Style, which is for code formatting. And so that was super easy to convert a Java file like this, which looked like this, to a text file that had my what file it was, my name at the top, the curly brackets on the next line, which I personally don't like, so I didn't want to write code like that. Yes, the compile script that Kearney has calls A-Style in your code. Code formatting is probably the most important thing for writing code. If it looks the way that, or if it looks consistent, it's 100% 100 times easier to debug and figure out what is going on. So back to my script, it formatted the code to look the right way, and it also put 2 runs or however many runs based on the input files that were given in that directory, and it would run with or would run your code with the input files, kind of like the way Kearney has his input tester set up, but I have that pipe the output to this text file for easier, alright, so I don't have to do it manually. So my first upper division class, we'll just kind of go in that order because that seems the easiest, was Multimedia Design and Programming. It was essentially the Computer Science 40, if you had Kearney, his image processing assignment, but for a whole semester. So basically we just took pictures and combined them together or did image filters on them, so there might be some manipulation. It's got a different image filter on for a few different ones, like top, bottom, here. Most of you guys could probably write that super easy. It's literally just for half the height, copy the 8 pixels to the bottom of the bottom of the image. Red eye reduction is also super easy, where you're just like, if it's close enough to the red color, set it to black. This is kind of bad because it's a very specific red, but it was supposed to just work for a single image. Kearney recognizes some places on my My favorite upper division class was something that you don't necessarily have to take, but I really enjoyed it. It was, where are you? Graphics programming. So in this class, I got to do a lot of stuff with WebGL and 3D rendering. If this will load, oh, there it is. So what you can see here is we've got a bunch of different planets. I don't know how to scroll on this. Okay, yeah. So we've got a bunch of different planets, and they're all rendered in real time, 3D, in the browser, using WebGL and JavaScript to basically render a solar system. That was my favorite upper division class. However, there are lots of other ones. That teacher didn't want us to put too much code online, so I only have the one example for that one. The next upper division class was software design, which was basically kind of learning how to design bigger projects. We made a card game, a casino game. For the final lab project, we were allowed to make a Android app, and I was TAing for the Computer Science 40, I believe, at the time. So I decided to make a Pokemon battling app, where you select Pokemon and their moves. And if you can tell, I do a lot of kind of Computer Science 40 assignments, slightly more complicated, to practice kind of other things. Then after the software design, we did some database management. From talking to other people kind of after getting out of school, is my schooling, or my program was a lot more kind of hands-on stuff and actually building projects, versus a lot of other upper division I've heard is quite frequently more theoretical kind of stuff. They're a rank of most to least used in 50A, B, 40. Well, 40 and 41 are probably the most used because it's literally the foundations of computer science. After that, I've probably used 45 the most, but that's because I run I run my portfolio as a web server off my Raspberry Pi. So I've done a lot of kind of system admin stuff that I learned through 45, which isn't really the point of 45, but it's stuff that I picked up along the way.
And they're not learning it this semester, unfortunately.
Oh, they aren't?
No, because
They're
there's
getting
no
around
there's no
doing
projects.
pies?
There's no
Oh,
pies. There's no projects. It's coronavirus.
that's sad.
Hmm. Yeah.
Projects is like the best part of 45.
Yeah, they basically finished the semester because without the projects, like,
Yeah, I've done a lot of different programming languages. From what I've seen, kind of applying to jobs, Java and JavaScript are probably the two most, but that's also because most of the jobs that I've kind of looked for are web design jobs. Um, and so what I do for work is TypeScript, which is a superset of JavaScript, where they added types, so you actually have type safety, because that's the biggest problem with JavaScript. There's no types. Um, and then a lot of old enterprise web apps use Java and Spring and stuff, which is stuff that I did a little bit in school as well. Um, Database management, which I believe SQL or writing sort of a SQL-like syntax is probably still a 26 assignment that Kearney does. Which is basically just really big Excel spreadsheets on steroids with programming for easily selecting and grouping large amounts of data. It's really useful and it wasn't too complicated. People don't fun sticks. Uh, it, it's the most different because kind of by the point you get to 26, you've learned pretty much all of computer science, so now you have to actually apply it, which is what you're doing a lot in upper division. They aren't teaching you kind of how to program anymore. It's now build something. Is the big shift from kind of the lower division to upper division that I found. So like in all of these classes, they kind of just assumed we knew how to program and didn't bother teaching us like any languages. Like the multimedia design programming was my first time ever writing any Python code, and they're just like, "Good luck." 26 is discrete math. SQL's a little bit disliked, but I don't think it's super not liked. We'll skip computer networking because I thought it was boring. It was interesting, but the class wasn't taught as well as it could have been. It was what along the lines of very theoretical, and we ended up not doing too much programming. Still only programming. But we were talking about kind of how network packets work and how the internet kind of talks to each other and everything, which was actually really important, but went into way more depth than I ever needed, so it felt a little redundant. Yeah, the SQL is probably one of the most real-world applicable programming sections, maybe? Because you're always working with databases, and Excel and Google Docs have a kind of sub-syntax of SQL that you can use for querying in their database, or in their spreadsheets, which I've used probably about as much as I've used SQL at this point. And then we did some internet programming, which was just their introduction to HTML, CSS, a little bit of PHP, and actually no, we didn't do PHP, we did Node.js for server side. And that's where I made the basic RPG game, which I kind of did a spin on one of the 41 assignments basically. So if I go to, I just search RPG here. I call it that? I think I called it that. Yeah. So in 41, you guys do an RPG where you have a map and everything. I had taken that. No, it's not this one. It's the other one. That one. Should be that one. Yeah, in 41, you do an RPG where you have to have a map. I had taken that code, which was originally in here. Um, all the cringe code for my bad code. So I converted or after I did the RPG in 41, I decided to convert it to being callable in JavaScript using WebAssembly, which is a magical technology that allows you to compile C++ and a bunch of other languages to being able to be called on the web with this fancy WASM extension that doesn't look good raw, so we'll not look at it. So I have my map, which might look familiar to you guys. Yeah, I showed Muya when he was in 41. I think that's when I kind of refined it a little bit. So this is just a big file. Did I? No. Yeah, look, I still have the 41 README quest for an A. .github.io/RPG game. So I called it Kawaii Squid for reasons. Um, the plot is basically you're a squid that lost your Suica card in the Tokyo subway, and you need to find your way out and get a new Suica card. So this, I see I have formatting issues. Cool. That squid you talk to, and it will ask you a basic riddle. So my layout of my game, let's see. If I inspect this, yes, you can see kind of all the basic text that's flowing along the side here. This is the layout of the map. It's all just using ASCII characters, which should look very familiar. The most important thing on my resume is having lots of projects. One of the things that a lot of the times I got, I guess, complimented for was the amount that I've kind of dabbled in a little bit of everything. So as you saw, kind of there was Java, JavaScript, Python, uh, and I've done a lot of different things with a lot of different technologies because I just wanted to try everything. um, so having that kind of depth of knowledge or that breadth of knowledge was really helpful. So the my schedule at Clovis Community was probably pretty similar to most other people, taking kind of a computer science class and then general ed classes. I actually ended up getting an associate's in physics because it sounded like fun at the time. And also, I didn't realize there was when I looked originally, there wasn't an associate's degree for transfer for computer science. So I got an associate's degree for transfer in physics instead. Still isn't. Oh, there isn't one still. Kearney keeps saying that there's gonna be one soon. And then when I transferred to CSUMB, um, last December, they finally said they're gonna think about fixing the problem at the state level. Okay. Um, and then at CSUMB, their online program is actually very different. Um, the way that they handle their program is you take one class at a time every 8 weeks. So they're all really short classes, but you get to focus on that one class entirely, which I really enjoyed because it gave you the time to just kind of dive into the topic and just work on that one topic rather than jumping back and forth between a bunch of different classes. And that was the class order is the order that I have in my portfolio, where it is just kind of chronological or reverse chronological because it starts at the most recent at the top. Um, so that just kind of runs. It calls the C++ every time it wants to talk to the backend, I guess. And and then transitioning from school to work life. Since I'd kind of been doing my yes, Muya, you can do basically all your backend stuff in C++ if you wanted to. The communication between C++ and Java or JavaScript is a little. I remember them saying it's a little unoptimized at the moment, so it's really only good if you have, or you're having to do in-depth kind of calculations. Otherwise, just using straight JavaScript is about as fast a lot of the times. Also, I believe there's backend libraries that are for C++ if you wanted to do strictly backend in C++. Um, so transitioning from school to working, since I was doing that kind of one project at a time or one class at a time program, it wasn't too much different other than now I have to do what other people want me to do rather than what I kind of want to do. Although school, you kind of do what other people want you to do at the same time. The thing that I was worried about a lot when I was transitioning from kind of school to working is I'm gonna have to be programming 8 hours a day, and I was worried that I wouldn't be able to kind of focus on programming for that long. Um, but when you're working, you end up getting, I guess, sidetracked a lot, where you end up kind of talking to your coworkers or in meetings and all that a lot more often. So you end up yes, Kearney, this is a meeting about yesterday's meeting. That's exactly how it goes. So it's not like you're sitting there focused straight 8 hours programming or anything. Um, at my current job, I probably spend 50 or 60% of the time programming. Let's see where. Okay. I'm working remotely, which is beautiful because I get to sit in a closet. I'm literally in my closet in my bedroom with a desk set up. The only work before graduating I did was TAing. I probably should have done at least one or two internships, or at least tried to do a little bit of programming work while in school. Because a lot of jobs will look for kind of internships, although they also conversely, a lot of jobs will say internships don't count as experience, which is really stupid. But have lots of projects and things that you can show off in your portfolio is what seems to be really impressive. Yeah, exactly. I saw that on a job application, and I'm like, yeah, I'm just not even going to apply to that one because I don't want to be there. Yeah, exactly. Let's see. The next cool class we kind of already touched on, which was graphics programming. Um, it was really kind of cool to do something in 3D space, if you have the opportunity, take IS-50 and IS-50B, because you do kind of the same thing, but through a game engine, which is a lot simpler than trying to write the actual individual objects. um, it's using WebGL, which is very similar to OpenGL. They use the same GLSL shaders, I believe. So you can see kind of the shader code, which looks very similar to C++, because I believe it's a strictly typed subset, or at least close enough. Um, so shaders are very cool, and you get to do a lot of fun things with them. It basically is how you tell the 2D plane that you're rendering on to interpret the 3D world. The next thing was the algorithms class, which was yes, the algorithms class, which was um, offered to do. You were allowed to do either Java or C++ programming. I happily chose C++ because it's stuff that I'd done in 40 and 41, and I kind of knew the standard library already. And then I found this video, or I guess talk about the world of the C++ standard library algorithms, and it made me really happy because almost 50% of the stuff in this class could be done through that algorithms library. So while other people were writing the program in Java, which doesn't have as in-depth of a algorithms library, I was writing it in C++, where we had to make a heap. My code ended up being 50 lines, I think, which was mostly just taking in inputs and outputting, yeah. Versus other people in my class that did it in Java ended up with, I think, 400 or 500 lines of code, which I thought was hilarious. Um, so there's a lot of things that you can kind of do with the algorithms library that makes life a lot simpler. Um, this specific one was kind of cool, using kind of matrices and figuring out how to draw a path where you pick up the most coins. That's what it was. Um, and so you did what they call dynamic programming. It's basically just, or I ended up doing something kind of more brute forcey, where you go through all the different ways and collect coins, and it returns a path, so that you could simply go through and test all the different options and then backtrace whichever one ended up the most at the end. Let's see, where's another one? Floyd's minimum path, you might end up seeing something like this in 26, I think. Oof, programming time complexity, yes. How often did you use fancy math and graphics? You do a lot of trig, but I'd say that's almost easier than a lot of calculus. um, and you do a lot of vector math, I guess. So it's a lot of adding and subtracting vectors. If I go back to that shader program, all these shaders is vectors, basically, or vector math, essentially. If it'll load, my goodness, my internet's being slow. Um, nope, that's a 2D plane. That's a 2D plane. Where's my vex? Oh, there's a vect. So it's literally just a vec2 for where you're trying to draw from the texture. Do I have a cooler one? That one might be cooler. Yeah, that one's cooler. So it's got a vec2 for the texture coordinate that you should be drawing, a vec3 for the world normal, and a vec3 for the world position. If I look up Phong lighting, there's probably going to be a good image on Wikipedia of a view stress frustum. Yeah, kind of. You get some vectors and stuff and scary notation, but it's not too hard of programming for the most part. Phong lighting. Phong. So after kind of the, after the graphics programming, I took and the algorithms class was a software development, which was kind of learning how real world programs are written. This was a cool class because we were writing a travel booking application, but my team only ended up doing was assigned to do the flights booking. So all we had to do was make a flights booking website and then expose an API for that, which an API is a application programming interface, so that other programs can talk to your program basically. Um, and then the overall travel agency website called each of the different teams APIs, which was a really cool assignment to kind of figure out how to talk to other people and communicate how that they could use your application. And then the last class was the best class because I got to decide I want to make a cool project. I completely over-engineered and went a little bit ambitious on what I wanted to make because I wanted it to be fun. So I made a game or a 2D game where you can run around and do objectives and fight other people. Oh yeah, and scary dragons because dragons are cool. Um, there we go. So I made it so that you can interact with the different abilities with other abilities, kind of in a rock paper scissors way of fighting. I wrote my own 2D game engine. I probably should have used someone else's. It would have saved me a lot of time. I also ended up creating a map editor, which was just fun to do. And I ended up with a stupid amount of code files, and I probably could have organized it a little bit better. So kind of the reason why I did it is because I'm doing other games, and then I found this thing to make an arrow look at where your mouse is, which looked like fun and could probably be used in a game. And then I've also watched a video about kind of how quad trees are used to do 2D space lookups, and it sounded like fun. Um, and so I had collisions, kind of, and actually be able to multiplayer between two different browsers and computers. Um, I'd recommend just kind of watching this whole thing if you're interested. Um, and it was just really fun to build a big project from scratch, doing what I decided I wanted to do. And kind of figuring out how to do all these different animations and stuff was really interesting. Yeah, that was all in JavaScript. The art for that was pulled from Open Game Art because I am a terrible artist. so it wouldn't have gone well. Yeah, it was JavaScript and Node.js. I really wish I used TypeScript in that project. I was originally supposed to have a partner for that project, and I didn't want to scare him by doing something too new. Uh, However, my partner never did anything on the project, so we kicked him off in the last week, and that happened. Uh, and so that was a really fun project to do, and took a lot of time. And it really kind of got me in the swing of like doing a big project and kind of architecting it, and then moving on to be able to do that in a real world environment for actual programming with a job. Let's see. I think that's basically everything from that. Let's see. Months. That I worked on that for about 3 months. Yeah, I'll dump my portfolio on here. Yeah, my capstone project took about 3 months. I also recommend looking at that site for kind of learning the C++ algorithms. Yeah, that my portfolio website's completely handwritten in Next.js, which is React.js backend. One of these millions of GitHub repositories that I've amassed over the time. And I'm probably going to rewrite it again soon. Because I found a cool technology or a cool runtime JavaScript runtime called Dino, which is TypeScript, JavaScript, server side, basically TypeScript, Node.js. No, I just like making things. um, it's a lot of fun to fiddle with side projects, and things are never done. Okay, job interviews. Yes, I'm sorry I missed that. So I've had kind of a few different job interviewing experiences. The first one that I did was kind of a more standard job interview, other than the beginning part where they did a typing test, which was kind of funky because they did a typing test and a personality test. I'm like, okay, whatever. And then they did the more standard kind of um, programming whiteboard interview, which was something that shouldn't be too hard for most of the people in this class to do. It was reversing a linked list, or no, it was sorting a linked list, which I'm pretty sure at the end of this class most of you guys can do. um, that was a interview for a embedded programs. I believe it was singly, so it wasn't as useful. Yeah, like writing C program for embedded hardware. Um, and then after that, they had me do a actual coding uh, problem, I guess. Um, that was something else to do with linked lists. I think it was. I don't remember what that one was. It was something else to do with linked lists, which again, you guys can probably do at this point. Um, and then the other kind of interviews that I've had are very much just kind of like talking about what I've done. The handy thing about the current day and age is that or most of the interviews have been over Zoom. So I've been able to just pull up my portfolio and walk through all my projects that I've done and explain them, and then they can get a very good grasp of like what I've done and what my knowledge is. Um, I usually show them my capstone project because it's a cool project, and it shows basically what I've done throughout my programming experience. I chose doing a multiplayer game pretty much for that reason because it showed a lot of skills that you'd learned in computer science, between data structures, where I did a quad tree, which is essentially a binary search tree in 2D, um, and then networking to kind of show the difference between um, or networking for multiplayer and JavaScript and web development for having the UI and stuff. And so it was a good kind of culmination of everything that I'd done and a quick, easy package to show off to people. Uh, how many jobs did I apply to? I think I had a list of about 200 applications that I applied to. So it takes a while. You just kind of keep sending them out there. I think I interview really well because it only took like 2 interviews to actually get a job. But once you got past kind of the how many accepted, I got I think 4 or 5 interviews out of those 200. Um, Job security. My current job, I feel very secure. My last job was fairly secure, but the company wasn't going anywhere. So I got a job out of school in October. I moved here to Texas in November. So I graduated in October, and it took about a month after that. And I was applying 2 jobs for a month or two prior to that. So it was about a 2-ish month job hunt. Um, and once I got the first job, um, the software architect at that job left the company, and so the whole team that was doing programming kind of fell apart. Um, and so after that, I kind of started thinking about looking for another job, and then the software architect that had left the company was like, "Hey, I have a connection that needs a front end developer," and I was like, "Okay, I'll apply." And then I got different, or I got moved to a different company that is now allowing me to work remotely, which is much better. Um, I moved to Texas for the job originally. The Yeah. So I was applying when I was still in Fresno. So, kind of moral of the story is have good connections in the industry if you can make them, which is probably more important than actually doing an internship. But why I wanted to do an internship is so that you would have to, um, or that you would have the ability to talk to people in industry. Um, I'd say I'm not taking classes anymore. Grad school, getting a master's degree is probably important if you want to, I guess, do something more serious. um, or I would have gotten a master, or I've been thinking about going back and getting a master's degree in kind of my spare time at some point. But for now, you can pretty much get a job with a bachelor's. It'll make you a little bit more competitive if you have a master's, but that kind of goes along with having more projects and stuff to show off in your portfolio. Um, Most of the jobs that I applied to were either stuff that had kind of silly. You see a lot of jobs that have very silly requirements. Like you'll see stuff for a language that's only been out for like 3 years with requiring 5 or 6 years of job experience, and you just kind of laugh at that. Um, So kind of applying to jobs is all over the place. I was doing about an hour or two every day job hunting in that 1 to 2 months. Yes, exactly. 25 years of experience with 20 years old.
All right. I do need to go over like one small little thing with my students before the end of class. But no, this has been really good, Mr. Bell. I really appreciate you doing this.
No problem.
Yeah. Class, you guys, I'll give them a warm thank you, series of emojis, animated GIFs.
Yes. Do that.
Vinny Blanca says, okay. But yeah, no, thank you. It was very, very cool. Go ahead and share my screen again. What is this? What the hell is that thing? Okay, so we're just going to go over Excel really fast because a lot of people I have found don't know Excel. So let's say that you run your timing script. I'll just get some data out of my implementation. I should have a reference. I deleted the timing script out of mine. Hash table reference original version 2. All right, timing script. And it's just going to do the mixtape one, huh? It's not good enough. Okay. Chmod user may execute. Timing script. All right. So if I run make clean, remove a.out, make the address sanitizer turned on. By the way, if you guys want your code to run faster, highly recommend adding that flag right there to your makefile. That can make the difference of a lot of time. -03 turns on the optimizer, and you might want to turn off the address sanitizer as well. That does slow down your code by like an order of magnitude, and sometimes debugging might matter. I don't think it will particularly, but you can turn off debugging information as well. So yeah, -03, get it tattooed on your arm. I don't know. Pretty important. All right, so let me run the timing script, and so it'll look something like that. Now, you got all this data. You need to put it into Excel. What's going on, girl child? You can fire up Excel. You can use any other spreadsheet program, really anything you can use to analyze the data. Excel is just kind of the easiest. And so I'm gonna just copy this text. If you're getting a lot of data, obviously what you want to do is redirect the output of the timing script into a file. Okay, like that. So if you don't know Unix by now, you should know Unix by now. That takes the standard output of the timing script and dumps it into a thing called out file. And so if you then out file, then it will be there, and you can SCP it over to your computer. If it's small, you can just copy the thing over. Either way. So,
Dad, what time are you done with school?
this is my long day, girl. I got IS50B after this. Do you want me to order some food for you?
Thank you. But what time will you end school?
It never ends, Ada. It never ends.
Okay. Well, when will you end school for the day?
3.
Okay. Thank you.
You're welcome. All right. When I did that, it just gave me the C out, not the times. The C out, not the times. Yeah, you might need to then do this. This just does the standard output. This with an ampersand does the standard output and the standard error. It depends whether you're writing to the standard output or the standard error. So do that, and then it'll pick up the standard error as well, and then you can copy the files over. Okay, so here we are. We got Excel. We got our stuff over here. First thing you need to do is you need to average these numbers together, right? And so there's a lot of different ways you can do that. I would probably, I don't know, what's the easiest way? Might not be the most efficient, but the easiest way. So we'll call this like insert search, and I only have 2 data points. Let me use generator first of all. Then generator cc insert search. Okay, cool. C++ -o generator.cc. Run generator like this. So generator 300,000 redirect into input search 300k. $400k. $500k. Taking longer every time. $600k. It's an order n algorithm, by the way. So $700k. And again, you can write a shell script to generate these things for you, if you like. This is just not quite long enough for me to worry about optimizing it. Okay. Then main.cc. Timing scripts. The timing script is going to run every command beginning with with the words insert search, and it's going to run each of them 5 times, and it will run it in linear probing and quadratic and double. This is the old assignment. Okay, so let's do timing script again here. What are the results? T, what are the results of the let's just run it first. So there it goes. It's off to the races. It's first doing 100,000, then 200,000. Did it not find the other ones? What happened here? Didn't I create insert search files? Check all these things. Input search. Damn it. Insert or input. Don't talk and type at the same time, kids. All right, fine. Move. Search. Okay. The input search 100k. Move insert search 200k to input search 200k. Vim timing script. So it is not input search. Oh gosh, input search. All right. So there we go. We're off to the races. 100k, 200k, 300k. Yep. And then I'm going to turn off address sanitizer, turn off debugging. And just for the hell of it, I will turn on C++ 20 mode. Add a clean target. Make clean, make. And then run timing script again, and you can see the times are a little bit faster now, right? So from 0.6 to 0.4, 0.8 to 0.7, right? So the address sanitizer does slow down your code a fair bit. Said you should remove address sanitizer. Yeah, that's what I just did in the make file right there. So -03, get rid of the -G. Leave address sanitizer in until you're sure that your code works right. Don't take it out until you're confident you're not going out of bounds. Okay. Cannot time run. Yeah, you need to build your executable first. And so, what we're going to want to do in Excel, and I'm actually going to stop this after running. It's taking so long. This is linear probing mode. You can see that it gets slower and slower and slower. So going from 900 to 998 takes more than twice as long. Right? Yeah, recompile your code, Thompson. All right, so here we go. I'm just going to stop it here and just show you how the process works in Excel. There we go. All right, so I'm just going to copy this over here. And honestly, what I would do is probably format the output differently so I can put it into Excel a little bit easier than this. Okay, paste. And what I'm going to do here is, how do I want to do this? There's so much better ways, but whatever. Okay, so in Excel, if you want to do a formula in Excel, so we've got 5 different runs for input search 100K in linear probing mode. We've got 5 different timing values. We need to average them together. So equals average is the Excel formula, and then you damn it, did I not type that right? Open parentheses, and then you select the data you want to average together, close parentheses, hit return. And so this number here is the average of the values. In reality, if I was to be processing this data, I would actually on the server probably write a small program that would read all these things together and do the averaging there. It's a little bit faster than doing it by hand like this. I hate tedious stuff. Anyway, so again, for the next one, equals average, and do this, these 5 guys, or you can paste each of these columns into a different. You can paste each of these runs into a different column, and then you can do a fill, and then you don't have to constantly type average over and over again. Like I said, there's a lot of different ways of doing this. In fact, maybe I'll do it that way. Yeah. That'll probably be a little faster. Cut, paste, cut, paste, cut, paste, cut, paste, cut, paste. These guys up, cut, paste, cut, paste. Like I said, I'd write a program to do this if I was doing this for real. Paste. And a lot of my professional career was actually doing a lot of analysis like this. Again, I don't do it by hand like this, but whatever. Okay, so now I can say equals average. And I can type it manually if I want. So in Excel, every row has a number, every column has a letter. And so you can express a range. Remember, we've talked about range-based stuff in C++. You can do a range in Excel by using a colon between the two. So I can say from A2, colon, A6, close parentheses. And so if you type that, you can type it manually, or you can drag to determine the range also. You see Excel colors it in there, hit enter, and that is the average time. And so let me right click, insert a column to the left, and I'll just put down here average like that. And then what I can do is I can just select the cells to the right like that, and then do a fill right, which is hidden behind my face. So Control R is one way of doing it, or you can click and drag on that little dot there, and that'll do a fill right as well. And so that is that. Graph it into a line chart, and there you have the running time of linear probing. Chart title. Linear probing, insert search. Okay. And so this is the percent load, and you'd probably want to change your axes and things like that. This is add a label for time, add a label for load factor, and you can see that linear probing kind of gets consistently worse until it gets really bad at the end. Okay. So, and then repeat this for insert change, insert da 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 da. Then do it for probing, or after you do it for probing, do it for chaining, and then you'll have a bunch of graphs. Or if you want to be cool, you can put all the graphs on top of each other. Either way, there's no particular format. Just make sure that the things are labeled so I know what I'm looking at. And then in your analysis, you're going to write up a little essay saying, linear probing seems to be pretty good at low load. However, there's like this hockey stick shape towards the high end, which it goes from bad to like really, really bad. And yeah, so don't use linear probing if your array's mostly full. Chaining supports the high end, high load better. Yeah. Let's write up a little paragraph of it. Okay, or not a paragraph, like a page, talking about which algorithm is better in which circumstances. And that's 10 points. Okay. That's the assignment. Okay. Just be aware that, again, the server is going to be crying on Sunday night. So don't wait till Sunday night to get your data. Okay, any questions? You're finished today? Good. Good. Might as well do a CSV at that point. Yeah, in all honesty, if I was doing this for real, I'd have the program itself probably output something in a CSV is an easy way of doing it. JSON's another way of doing it. This is a very lowbrow way of doing the analysis, but I always like to start with like really basic stuff first. And then if you guys are like, you know what, I'd like to not have to copy paste it, but just have the program generate a CSV file, do it. Nobody's stopping you. Nobody's stopping you. If you have a better way of automating, and there's lots of better ways of doing this assignment than what I showed you here. I'm just showing you the bare bones minimum. Copy paste into Excel, average the 5 numbers together, graph it. That's the lowest tier level of analysis. If you want to do better, have your program itself read through all the input files, do the averaging of times, dump them into a CSV file, have Excel load up the CSV file and graph it. There's a lot better ways. Or dump it into Excel database. You can spend as much time on this as you want. Okay. Yeah, you can change the formatting of what you output, right? Okay, that is it for today, guys. Have fun over the weekend. Work hard. We'll probably do another benchmarking assignment in May, so get used to it. Don't punt on this one. It's not too bad. The coding itself, like I said, it's this much code. It's really not a lot of code. Easy 10 points on the code, and then learning how to benchmark is going to be a great life skill for you guys. It's honestly good for you, like broccoli. All right, see you guys.